Hello everyone, this is the video lecture for Pre-Calculus, Chapter 6.1, Angles. So, before I even get started in Chapter 6, I want to tell you that at some points when we've still had this book and still had WebAssign, we sometimes switched 5 and 6, Chapters 5 and 6. So basically, some semesters in the past, students had done Chapter 6 first, and then they did Chapter 5. And then we switched it back to having 5 and 6. The book is kind of designed to do that. I'm telling you this because we're going to see a lot of review, a lot of things that like, oh, we've already seen this. So, like, especially after the section going on to like section 6.2 and onwards, it's just going to be what I've already told you. So we'll just be seeing the same stuff again, and that's okay. It will change. It will get different. And there will be new things, and so you'll see a lot of new things in this section in particular. So here we go. I'm going to just start right off with one of the first questions. They're dealing with formulas. Basically, it's one of those questions where you get it wrong 3 times, you see their answer, you go back, and you put the same things in. It's just formulas, and so I guess I'm telling you the formulas again. So radians equals degrees times pi over 180, just like that. And degrees is equal to radians times 180 over pi. So honestly, I can't quite remember if we've seen these formulas or not yet. I know we used the unit circle a lot back in the day. That's fine. But these are the formulas that you can use to convert back and forth. What I like to always think about is like radians in particular. Let me just, make an example, say 2 pi over 3 or something. If I multiply this by the 180 degrees over pi, the pi's are going to cancel. That's what's indicating to me that I'm going to remain now as a degree. See, the degree symbol is still there. So that's cool. Another way going the other direction. Let's just say I had like 60 degrees. And I multiply by pi over 180, well, notice my degree symbols cancel. And I'm retaining a pi. That's telling me that I'm going to end up with a radians in the end, okay? So that's how I remember it. If I'm getting a degree symbol that cancels out, if I'm leaving a pi behind, then it's radians, So here we go. That basically you just put this in for your answer somehow. Again, I can't exactly remember how it works, but it looks like that. Do that. The next one is omega. We got omega is equal to theta over t. And this is supposedly angular speed. Now, if they're needing you to put thetas and t's and omegas, I think you can actually write theta, and when you write that a, it just automatically transforms the whole thing to a theta. Same thing with omega. I'm pretty sure that just happens. Or again, you can go to that little tab on the right side and just find the symbol. V is equal to s over t. This is a linear speed. And V is equal to omega r. All right, what's going on? Well, angular speed is how fast you're going around a circle. Linear speed is like at any moment how fast you're going. This is kind of like the speedometer. So imagine you're in a car and you're like just doing donuts in the parking lot. Hopefully not, but you get the idea. I'm just going round and round and round or something like that, and I want to know what's the speedometer say, right? Versus like how fast I'm going around in a circle. How many times will I go around every minute? How many times, that kind of thing. How many revolutions per minute? How many degrees per minute? That kind of thing, okay? And then there's a conversion between the two, a formula to convert them. Okay, now that we got those done, let's actually do some math. They got negative 52 degrees is equal to blank radians. And so, just negative 52 degrees times pi over the 180 degrees. Notice that my degree symbols cancel. So I basically have negative 52 over 180 pi. And you don't have to simplify. So that's an appropriate answer. But I think that the WebAssign is wanting you to do a decimal. So you would have to use a calculator. Now it's kind of interesting. some folks ask me at this point, say, hey, do I need to be in degree mode or radian mode? It does not matter what mode you're in right here because you're just getting a decimal. Okay? You're just getting a decimal. We'll change degree and radian mode later when we're talking about sine and cosine again. I think that's the next section. Okay. They got 140 degrees, so equals blank radians. Same procedure, 140 degrees times pi over the 180. Again, I'm verifying that I'm doing the right formula because I can cancel my degree symbols out and get something that I'm needing. And I got 2.4434. Again, these are all radians. And sometimes I believe that the problems don't always use like the rad symbol and all that kind of stuff. So we're kind of just making sure we're doing it right. 61020. So I've got negative 3 pi over 2 radians is equal to blank degrees. So I want you to notice that degree symbol there. That's important. Again, will they always put a rad there? I can't remember. I know on the next problem they won't. But I'm saying, watch out. If they're wanting degrees in the end. They're not going to say degrees. They're just going to have a little degree symbol. Okay. Negative 3 pi over 2 times 180 over pi. Again, remember, my pi's are going to cancel. So that's kind of my indicator I'm doing it correctly, you know. And so, blah, blah, blah. You actually get a negative 270 straight up. You're going to put this in the box because they already provide the degree symbol. 61023. So negative 1.6 is equal to blank degrees. And you're like, what? Well, this is radians. They're not going to say that, I don't think. I have it in my notes that they don't say that. So I'm just telling you, watch out. If it has a degree symbol, then it's degrees. If it does not have a degree symbol, then it's radians by default, I guess you could say. So this is going to be a radians by default. Notice also it does not have a pi. So whenever I start like multiplying stuff here, normally I have my pi's cancel out. You know, I would say, oh, cancel pi's on both sides. Well, I don't have that. It does not mean I'm actually doing it wrong. It's just a rare occurrence where I can't just cancel pi. But I can still put that all in a calculator. I got a negative 91.6732. Again, that's degrees. Okay. I got like so many different ones we can do. We can do a ton of those things, but you can see it's not that hard. I'm going to move on. 61034. So they start with the negative 135 degrees, and they need 2 positive and 2 negative coterminal angles. Well, what does that even mean? Let's think kind of like unit circle. 135 is somewhere down here. Well, actually, whoa. Negative 135 is somewhere down there. Right? Negative means we're going this way, right? So this is where I have my first answer. They're saying, okay, well, there's got to be some more that are on the same line, coterminals, same, literally copy-paste. Couldn't I go this way one time? Couldn't I go around one full loop and then back to it? Couldn't I can go once this way, but I already have that answer. Go full loop, and then I can go 2 full loops. Basically, what I'm going to be doing to get this math, it's actually very simple math. I'm going to take my original, and let's add 360 to that. So I'm going to add 360. So negative 135 plus 360 is going to be 225. That's one of your answers. And then I'm going to take that answer, and I'm going to add a 360. And I got 585. So that's one of your answers. So I got 2 positives. Now how do I get the negatives? Well, I'll start with that same original. I'm going to minus 360 from it. So negative 135 minus the 360. I got negative 495. That's one of your answers. I'm going to take that negative 495 and subtract another 360 from it. And I got a negative 855. That's another one of your answers. Notice, did I get 2 negatives now? Yeah. There you go. There's your 4 answers. Not too bad. Just keep adding and subtracting 360. Eventually you'll get all the answers they're wanting. So they give me this formula for arc length. For arc length. Try to write that correctly now. Is S is equal to R theta. My arc length S is equal to R times theta. The one thing is that theta must be in radians in order for that to work. For this problem, they give me R equals 2, theta equals 124 degrees. And they say, what's S equal to? Well, so, like, what does this even mean? Actually, they even include a picture. I just noticed that they also include a picture. The picture actually has this right here as my theta, but they say that this guy here, this other thing, that's my S that they're wanting. And R is, of course, my radius there. So they don't want this. In fact, because I don't want to get anybody confused, I want to erase this amount right here so that you're not confused. We're not looking for that arc length. So arc length is that, well, it's this amount on the arc of the circle. So we're going to use this formula, but notice that it's at theta in radians. I can't use 124. Basically, if I were to say S is equal to 2 times 124, that is wrong. That is so wrong. So, and I'm using the wrong angle anyways. Notice the angle here is something different. So in order to get this angle inside, what would I do? Like instead of the 124, well, I'm going to say the 360, a full circle, minus the 124, should give me that other angle. So 360 minus the 124 is 236 degrees. That's the angle I actually need to use. So, okay, so it's 2 times 236 degrees again, right? No, you need to have it in radians. So I'm going to convert over to radians by saying the 236 degrees times pi over 180. Again, notice my degree symbols are going to cancel. And let's just go ahead and put this into decimal form, 4.118977. Should be good enough. Cool. So that's my radians now. Now, can I do S is equal to, again, R theta. S is equal to 2 times 4.118977. And finally, the answer is yes. That's good. 8.2379. And again, this is in units. I don't know what kind of units it is. Inches, meters, whatever it is. But I have something here on my notes where this was not sufficient. They might need exact answers. Okay? Again, I'm not 100% sure on that. Things change. We have different kind of problems. I'm not saying like I have a different problem on this number here. I'm saying that, not just this problem, but another problem might want approximate. Another one might want the exact. I don't know. So if we want exact answers, I wouldn't go this far. I wouldn't go that. I would actually just stick with this guy right here. And so then I got S is equal to R theta still, but now it's 2 times, and I just basically have 236 pi over the 180. Okay, and you're done. I mean, there it is. That's my exact answer. You do not need to simplify. If you want to simplify, that's fine. There you go. Again, that's in units. But you do not need to simplify for WebAssign. Okay. 61059. My radius is equal to 6 meters. I have an arc length is equal to 7 meters. So this is S. This is R. And they want to know what is theta in radians. Well, that's super easy. S equals R theta. We already have some of those. So 7 is equal to 6 times theta. Divide by the 6. I got 7 over 6 radians. And I know that it does not have a pi, but, that's okay. 7 over 6, put it in, you're good. They also want this in degrees. Well, then what I'm going to do is take that 7 over 6 answer and multiply it by 180 over pi, okay? Now notice I'm going to retain my degree symbol here. So it's going to be a degrees in the end. If they want an exact, you could just basically just put that in. But if you want to do the calculator, that's fine. I got 66.845, again, degrees. Okay, kind of depends on what they're wanting. 61063. So they have this circle here. I'm trying the best I can here. Circle. And they got a radius of 2. And I have this arc here that's 72 degrees. Okay, 72 degrees. And they want to know what the area is of that. So the area of the sector. Well, let me give you the formula for that. I can't remember if they provide it or not. If they don't provide these formulas in the problem, you can do the read it, which goes to the ebook. Of course, that's not my first suggestion. I'm just glad that you can watch this video and you can get the formulas here. And of course, we got the formula book on Blackboard. So you just go to the formula book, you go flip to the section of PreCal, and it should have all these formulas there. Maybe not in perfect order, but certainly if you find area of a sector, then you're good to go. Okay. Theta here has got to be in radians, just like last time. And so 72 degrees is not going to work. I need to multiply that by 180. Nope, it's pi over 180. Remember, because my degree symbols have got to cancel out. Okay. I think they're wanting to have the exact answer in the end. That's what I've got boxed in. So I'm going to basically keep it this way as an exact answer. So that's my theta. That's my radians there, okay? So I got my theta. I got my r is equal to 2. R, theta, everything else should be fine. Here we go. 1/2. And then theta is 72 pi over 180. And then my r is a 2 and square it. That is your exact answer. You do not need to simplify. And I don't know if it's been that some of y'all have asked me about the simplify, but certainly I've had questions. So that's not radians, that's area now, which would be, I think, meters squared. Did they say meters? They just said 2. I'm going to say units squared. That's an area. Okay. Sorry, I was confused for a second. I've had some questions either from y'all or from some other semester or something or other about format, the format of the questions. Basically, you're sending me a question saying, hey, WebDesign's not taking it for some reason. Often it's like a typo or something. That's honestly what's going on a lot of the times. So one of the times I was just confused altogether. Like, it looked perfectly fine. I didn't know what was wrong. But and that's just computers. Computers can be a little weird like that. Continue sending those to me. That's fine, of course. I don't suspect that many of those issues are because you don't simplify. That's not the point here. You do not need to simplify. I'm telling you straight up. If it's one of those, I call it the fancy box, where you can, it's a big old box and you got the tab on the side, you can put fancy math in it. If you got a fancy box, do not need to simplify, okay? So if they're not accepting it, often what I think of is that it's like a typo of some kind, or maybe just the computer being weird. Like, often what happens, like, where we can't see it, is like a invisible space was included, and so the computer doesn't understand space. It thinks that it's trying to be a number. It's not a number. It doesn't understand, so the whole thing's wrong. Those kind of things happen, of course. You talk to me about it. You send it to me. We'll look it over, of course. But again, I'm saying it's probably not the fact that you didn't simplify or something like that. WebAssign, you do not need to simplify. I'm going to keep saying it forever. So area of a sector is the next problem. So they say the area already is 65 and then meters squared. They have an angle of 140 degrees. What's the radius? That's not too bad. I'm going to provide a picture. Maybe they provide a picture. Either way. So it looks something kind of like that there. Cool. Well, I have a formula. Area is equal to 1/2 theta r squared. And I have my angle kinda. I definitely need my radius. I don't have that, but I do have my area. So my theta was going to be the 140 degrees, but I have to change it into radians. So I'm going to do pi over 180. Okay. Cancel these guys out. I'm actually going to use my calculator on this guy. The end of this problem is like just decimals, which is easy, I guess. 2.44346 radians. So we'll be using that in my formula. So here we go. A is equal to 1/2 2.44346. That was my theta. R, I don't know, and it's squared. And my radius, my area, sorry, they had told me was 65, just straight up. So that's kind of like my formula right there. Solve for R. Well, in order to do that, I'm going to take this stuff and move it to the other side. So R squared is equal to 65 divided by half times the 2.44346. I'm going to put that in the calculator. On my paper, I did not do it this way. I simplified at the very, very end. I think that this will still give us the right answer. So obviously we'll compare that here in just a second. So that's my R squared. To find R, to get rid of the square, you square root both sides. Now, when you square root both sides, normally we say like plus and minus, but we're talking a radius here, which is always positive. So just put a square root. Also, I'm not really just square rooting these 4 decimals here. Obviously, we'd have huge rounding issues. In my calculator, it actually looks like this. It looks like square root of answer. And so then I got 7.29405. That actually is identical pretty much. So there you go. And that, again, is a radius. I think they were talking, this is in meters. Was it meters squared or something like that? Yeah, meters squared. So then this would be meters. Cool. Next one. 61075. Oh, whoa. One last thing. Remember how I say you don't have to simplify? That's fine, of course. If it's some kind of decimal here and you're getting it wrong and it's off by just a little bit, that is totally possible. WebAssign does have some amount of percentage error, leniency, I guess you can say, and that's fine. But it doesn't have a lot. Sometimes it's almost none. So that can be one issue if it's trying to be picky. Of course, if you go and type it in 3 times, you get it wrong, and it looks almost the same decimal, but it changed this guy to like a 4 or something, well, then you would know that it's just being really picky about rounding. Next time you do it, don't round like I did, because I'm not perfect. So, car wheels at 28 inches in diameter. You could tell it was a word problem. So we have some car wheels at 28 inches diameter. How many miles? Traveled if you were to revolve it, or it revolved 10,000 times. Now you're thinking 10,000 times your wheels go around. That's a lot. I don't think that's a lot. I think that's, honestly, you got a wheel, you're going 10,000 times around. You're probably doing that just driving to school or something. So how are we going to get this to work? Well, it says how many miles travel. Let's just talk about this. We got a wheel on a car. Let me just kind of, it's probably like a bicycle wheel. There you go. And let's just say I put like a tag or a piece of paint or something. I'm just going to make sure to mark right here. And as I travel, just put the whole paint on the whole darn thing. As you travel down the road, that indicator, that mark, is going to be at different locations until it comes back to the same place again. You see what I'm saying? It's going around and around and around and around until you come back to the same thing. This right here would be 1 revolution. So how much, if you were to cover the outside in paint, how long would that strip of paint be? Basically it would be, what's this distance here? I know that we went 1 revolution, but what was the distance, like, in inches or something like that? Well, that is the outside of the wheel. It's this guy. It's the circumference of the wheel. You would basically roll the wheel out. I guess another way, what if you took the tire and you cut it right here, and then you rolled it flat, and so you're rolling it out flat. And this is, obviously it's too long in this particular case, but you get the idea. I roll it out flat. Here's all your treads. On the inside of the wheel, it's all just, whatever's on the inside of the wheel. I guess it's smooth or something like that. And so how much length would that be? And so that's that circumference. I'm going to go ahead and tell it to you. It's 2 pi r. 2 pi r. Area is the pi r squared. Circumference is the 2 pi r. Okay? So how am I supposed to find this? Well, I need a radius. I don't have that. I have a diameter. Well, a radius is super easy because it's half of the diameter. Diameter is the full distance across. Radius is only going to be 1/2 of that. So I'm going to say half of the 28 makes 14. And so this is inches still, but that's my radius. So 2 pi times the 14 is, 28 pi. And that's going to be in inches still. This is my circumference. Circumference. It's also a distance traveled with 1 revolution. Distance for 1 revolution. Okay? Now, I didn't simplify it yet, but you get the idea. It's kind of weird that we divide by 2, and then all of a sudden I multiply by 2 again. This is that S equals R theta kind of stuff, but, moving on. Just saying it. We have the formulas, we've been using them, but there we go. Okay, so I have some amount where I'm going to be revolving it that many times. Well, guess what? They said, how many revolutions? 10,000 times. So I'm going to say this amount times 10,000. So 28 pi times the 10,000 equals, and what do we get? Well, a huge decimal number. 28 pi times 10,000. And I've got 87964.943. Guess what? Inches. So you're going to work or you're going to school, and you travel. You go and tell your friend, "Oh man, I did a big trip today. I traveled a whole 800,000 inches." And people are like, "What? That means nothing to me. Did you go to Oklahoma, or did you just go down the road to the gas station? I have no clue." We don't think like that, So, and neither does WebAssign. They're going to want to convert it into miles eventually. So, what I want to do is convert this into miles. How do I convert these crazy numbers into something I want? Well, I'm going to show you how this works. It's actually kind of like chemistry in a way. I got inches. The next thing up from inches is feet. So I got 1 foot is equal to 12 inches. Okay. Now I chose that because if you notice, my inches are going to cancel, and now I'm left with feet. Well, the next one up is miles. There's 1 mile for every 1 mile. How many feet? It's 5280 feet. Foots, feet. Anyways, they cancel. And so this is how I'm going to get that. I'm going to basically divide by the 12 and then also divide by the 5280. If you are not familiar with this number right here, sometimes I forget it myself, you need to write it down on a note card or something, okay? Something like that is very possible to come up on an exam. So please keep that around. Go DuckDuckGo it or something right now to verify that I'm doing it right. For a long time, I thought it was a 6 instead of an 8, and I was wrong. So I got 138833, and this is now in miles. Okay, so watch out. This is a very important number. Go and find it. Double check me on it and all that kind of stuff. Okay, so I traveled 13.8 miles, so I did not go to Oklahoma. There you go. If you're wondering, I'm in Texas. So there you go. I know this is an online class, so a little weird sometimes. We could be anywhere. Who knows? Okay. This last problem that I'm going to do, it has a name, and you know how I am with problems with a name. It's called the cow problem. if it has a name, it means that it's very particular. This one, in very much particular, is one that I get asked about a lot because it's just confusing, honestly. And it's not difficult. It's not difficult. I'm going to tell you right now, it's not a hard problem. But it's confusing about what is going on here. So try to, go through this with me. If it was still confusing, or when you get to it on the homework, do what I'm doing, but maybe like rewind, pause, that kind of stuff. Okay. Of course, you could still ask me questions, but honestly, I'm going to do my very best to do everything we need here. Okay. So we have some kind of weird shape of a barn. Okay, that's supposed to be a barn. And a cow is tethered with a rope right here. And, well, I'm just going to try to make this a cow here, okay? Here we go. And then we got the horns. Okay. There's my cow. Well, I'm not an artist. So we got a cow tethered to a barn. And they're giving me distances for this barn. They're saying that this distance here is 70. This distance here is 60. We got 10. And here we got 60. Okay? Though I don't think that's going to matter anyways. So I got distances of the walls. Okay? And they're wanting to know what's the total area that could be grazed by the cow. What's the total area? Hold on. Total area that the cow can eat. Okay? Like grass, Well, think of it like this for a second. I'm going to break this problem down into something that's manageable. Can the cow move back and forth this way? Yeah, of course. I'm just going to the maximum. Cow could be down here, but everyone knows that. I'm just saying, how far can the cow stretch out, So definitely for that. I'm going to break this down into this chunk. You can see this is like a quarter circle. It's a quarter of a circle. Okay. Oh, I forgot one thing. This is a 100 right here. And these are all in feet, by the way. So that's a 100. So my quarter circle here is 100 feet in radius. Let me find that area first. So I'm going to call this area right here area 1. So area 1, the same formula, 1/2 theta r squared. What's my theta? What's my angle in radians for a quarter circle? It's actually pi over 2, 90 degrees, basically, if you go to the unit circle. And then so 100 squared. I go and put all this stuff here into the calculator, and I got 7853.9816, and that's feet squared. Okay, so this is not your final answer, but this is very good. That's one good step. The cow could go all the way over here, right? But what happens is the cow keeps going, but the rope is stuck right there. Basically, the rope would be right along the wall, and then all of a sudden it kind of branches out a little bit. Notice that this length of rope here that I can get out is not 100 anymore. It's not 100. This is not a 100-foot rope. This was 60. 60's already been taken up, so this radius here is actually a 40. That's a 40 radius right here for this little guy right here. Okay? Because again, it's sitting on the side of the barn. We already used up 60 rope from the corner, so there's only 40 feet left because 100 total. Okay, so this quarter circle, I'm gonna do A2 here. Let's just say, let me write that over here. Okay, A2. So A2, same formula, 1/2 pi over 2. It's got to be in radians, and then my new radius for that is going to be 40 squared. Calculator. And I got, right, let's see what I got here, 1256.6371. And that's feet squared again. I'm not going to box it. This is good. It's not my answer, though. Notice that if the cow were right here, the cow can still keep going, right? Just a little bit. So if right here, let me use a different color so you can see here. I got my rope. This is my rope here. 60 and 10. So what would be left this way now? What's left to go out all the way out this way? Well, I had 100 feet minus 60. It's pivoting here at this guy, so minus another 10. So that's 70 already used up. and 100 minus 70 is 30. So I've got 30 feet of rope. I know not to scale. 30 feet of rope here for the cow to still eat. Okay? I know this sounds really weird, but I mean, well, that's how it works. This is the problem. So 1/2 pi over 2. And then we still, again, that's still the same quarter circle. It's just a new circle at 30 for my radius. And I've got 706.8583. Again, feet squared. Again, that's very important. The last bit that we haven't talked about yet is down over here. The cow can go down here, right? And then the cow can keep on going down. But notice again, it's touching the corner of the barn and it's pivoting. And he'll end up somewhere down here. It's basically the idea. There we go. So it's still a quarter circle. Notice that I have 100 feet, and I've already used 70 of it. 100 minus 70 is only a 30 radius. A 30 radius to get out here. Okay? So this little quarter circle here, the last one, I'm going to say this is A4. 1/2, a quarter circle. Everything's a quarter circle. And then I got another 30. I think we get the same number twice, don't we? Yeah. That's 706. 8583. Cool. I'm going to just redo this one in green. Just a little bit so we can get different color variations. So this guy's going to be in green here. There you go. Whatever. Green. Okay. Cool. Adding all these different areas up. 1, 2. This is going to be 3. I know it shouldn't be in green, sorry. And 3 and then 4. I'm going to add up all this area that the cow can eat, and we should get an answer, okay? So 706.8583 times 2, because there are 2 of those guys, plus the 1256.6371 plus the 53.9816. Add it all up, I got 10524.34. And that's what they're going to want. This is feet squared. 34 feet squared. Oops. Well, now it's zoomed in. And that's it. Cool. And actually, we're done with that section finally. So there's the cow problem. It's a pretty difficult one. Again, if it's kind of a little confusing, go back through my reasoning for this, okay? You can even draw separate pictures of it all. Whew. Y'all have a great day. Thanks for watching.